In this section, we're going to talk about trig identities. Now, there are some fundamental identities, and by identities, I mean things that are given to be true. Relationships that are always true, okay? Kind of like sine is always opposite over adjacent. Well, these are true as well. And so these are things you don't have to memorize, but they will be on your chart, but you'll be familiar with them, okay? And they should make a little bit of sense. Look at this. Sine is 1 over cosecant. So this means if I take the reciprocal of cosecant, isn't that sine? Yes. Same thing with cosine and secant, tangent and cotangent. Those are based on your basic trig ratios. And then we can reverse it. Look, we can say cosecant is 1 over sine. And we use this property a lot, don't we, when we do triangle or calculator work? Secant is 1 over the cosine. Cotangent is 1 over the tangent. We use these already. These are identities, things that we know to be true. So we can replace cosecant with 1 over sine in the problems we're doing. Now, there are some quotient identities. Quotient identities just mean what? Division. It just means division. No big deal, okay? So these are identities that we will be using. Look at this. Tangent is the same as sine over cosine. And that should make a little bit of sense because that's like on our unit circle, it's like y over x, isn't it? And sine is y and cosine's x. Well, then the cotangent is just the reciprocal, x over y. Or we can put it in terms of the trig functions, cosine over sine. So that's where the quotient identities come from. Now, then there is the Pythagorean identities, all right? Now, these guys are based on, just like it sounds, the Pythagorean theorem. Now, if you want me to show you the proof on these, I can, but I don't want to do more than I need to on this video. There's enough conceptually going on. Now, the Pythagorean identities, there are some unique features, okay? With these, everything is squared. Everything is squared, if you notice that. There's squared powers on all the trig functions, and they all have a value of 1. Somewhere in the identity. This one is sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. You don't have to understand the relationship. I can show you if you'd like, but this is just the identity. What does that mean? Why do we want to use this? Well, that means that in certain cases, I can replace a 1 with this because they are equal. Or I can replace 1 plus tangent squared with secant squared in a problem. Or I can replace secant squared with 1 plus cotangent squared. Maybe that makes sense in terms of the question. Now, the nice thing about the Pythagorean identities is there's things we can do. We can do a little algebra and rearrange. Because what if I wanted to solve for sine squared, right? If I wanted to solve this for sine squared theta, all I would have to do is subtract cosine squared theta, right? And now I have an identity where sine squared theta equals something, right? I could use that in a replacement. Or I could do cosine squared theta. What does that equal? Well, it's just 1 minus the sine squared theta. So there's 2 ways to rearrange that one. What about the next one? Same idea. We're just going to do a little bit of rearranging. So what if I want to solve for 1? 1 would equal secant squared theta minus the tangent squared theta algebraically, right? What if I wanted to solve for tangent squared? Oh, I could just subtract 1 from both sides. So keep in mind, those are possible trig identities. Even though you may not see them in this form on your chart, you have this form and you do have the freedom algebraically to rearrange as needed. Let's look at the last one. Cotangent and cosecant. What do we do with this? Well, it's just some algebra, just some rearranging. If we solved it for 1, we would have cosecant squared theta minus cotangent squared theta, right? Or I could solve for cotangent squared theta, and I would have cosecant squared theta minus 1. So again, more identities I can use to solve. Now, where would you solve this? What are we doing? All right, look at this at the bottom. Here's some sample questions. When you do trig identities, you are transforming one side of the equation to the other. That's exactly what you're doing. And don't worry about this notation. That just means it's all happening within the first quadrant. Doesn't really matter in these situations, but we're trying to make the left side equal the right side. All right, I always start with the left side and make it equal to the right side. So start with something you know is true. What could we do to replace one of these trig ratios to get us to a 1? Well, if you look at the top of your page, we have those original trig functions, right? What do we know secant as? Secant is, secant is 1 over cosine, right? 1 over cosine. So I could replace the secant with 1 over cosine, and look what happens. If I do cosine theta times 1 over cosine theta, I'm going to put a question mark because I don't know if it's true yet. We're trying to figure that out. Now if I multiply these, or you can cancel them, now you would have 1 equals 1, and you've finished your identity. So it's a replacement process, okay? So let's revisit what did we do. We replace secant with 1 over cosine, right? Let's try the next one down here first. Tangent and cosecant time equals secant. Okay, so what the heck? Where are we going to go with this? Well, usually a rule of thumb I use is to try to get things in terms of sines and cosines. All right, so knowing that, I'm going to use the quotient property and replace tangent with sine of theta over cosine theta. That's one of my quotient identities right here. All I did was replace tangent with that. Cosecant, I want to put it in terms of sine or cosine. Well, cosecant is 1 over sine, isn't it? And then I'm checking to see, is it equal to secant? Well, it doesn't look like it yet, but let's see what happens. Now I kind of lean back and go, look, I can cancel out the sines, can't I? And then when I multiply my fractions, I have 1 over cosine theta. Does that equal secant theta? Well, one of our reciprocal identities at the top, it does. So we can rewrite this. Secant theta equals secant theta. Once you have them equal, you're done. But you have to show your steps. You have to show the work. Now the next two look a little more cumbersome, but we can do this. Now, look at this. Notice for a second, these are binomials. When you multiply binomials, you got to do FOIL, right? But before we jump into that, I want you to notice that these are the same, tangent, tangent, and you have a plus and a minus. So it's really a difference of squares. So watch what's going to happen here. When I do my FOIL, I'm going to do secant squared theta minus the tangent of theta times the secant of theta plus the tangent of theta times the secant of theta. It just looks really weird. I get that. And then I do my last terms minus tangent squared theta equals 1. So I'm still trying to get the left side equal to the right side. Now I notice that these two cancel out, right? And then what do I have left? I have secant squared theta minus tangent squared theta equals 1. Now, this is not one of the Pythagoreans, the original, but it is one of the iterations of it, right? One of the rearrangements. Isn't that secant squared minus tangent squared equals 1 right there? So I can use this replacement. I can replace this messy side with just a 1 and finish my identity. So all of this gets replaced with 1, and indeed it does equal 1. Okay, look at the next one. This one's going to take a few more steps, but let's just hang in there. All right, so the first thing I would do is separate this fraction on the left. So here's what I mean. I would write it like this. Tangent theta over tangent theta plus cotangent theta over tangent theta equals cosecant squared theta. We don't know that yet. We're trying to figure that out. Okay. Now, hopefully you catch the tangent squared over tangent squared is 1, isn't it? And then this guy, cotangent theta over tangent theta, now I'm going to split this guy up. So it's cotangent theta times 1 over tangent theta. See what I did there? I split it up. Why the heck would I do that? Because isn't this right here cotangent? And then I can replace it and do 1 plus cotangent squared theta and see if it's equal to cosecant squared theta. Is it equal? Well, let's look at our identities. Look at this identity right up here. Isn't that it? 1 plus cotangent squared theta equals cosecant squared theta? Yes, so I can finish it. Cosecant squared theta equals cosecant squared theta. So these are kind of hard. It just takes some thinking and replacements. Just think replacements and equal properties. I very much encourage you to work together, ask questions, but definitely don't give up. I find these to be very fun, but I'm a nerd, I know that. So try these out. Let me help you. Don't get stuck. Good luck.